So far, we've created the contract that will define what the database looks like for the rest of the application, but we haven't really created the database yet. To do that, we need to create a new class known as DB_helper. Because we will be using SQLite as our database, we'll extend the Android class SQLite OpenHelper to create our DB_helper. SQLite OpenHelper exists mainly to take care of creating the database for the first time and upgrading it when the schema changes. The DB_helper also provides other classes with a reference to the database, giving them a way to access its information through queries. SQLite OpenHelper provides us with two important methods, oncreate and onUpgrade. Oncreate is responsible for creating the actual database for the first time, while onUpgrade is responsible for making sure the database schema is up to date. We'll be overriding both oncreate and onUpgrade in our DB_helper class. In exercise 2, create the database. Open up waitlistdbhelper.java and modify the class declaration to extend SQLite OpenHelper. Inside the DB_helper class, create a final string called database name to specify the database file name. Let's call it waitlist.db. This will be the name of a local file on the Android device that will store all our data. Then create another final integer to store the current database version number. This should always start from 1, and anytime you decide to modify the database schema in your code, you should increment it. This will force users to upgrade their databases whenever you release a new version of the app. Also, don't forget to change the contract if you ever do change the database schema. The constructor shouldn't do anything special here, so let's just simply call the parent's constructor and let the parent class handle everything for us. To call the parent constructor, call super and pass through the context, which is usually the calling activity, the database name, and the version number. This null argument is supposed to be something called a cursor factory, but we won't be using one in the scope of this app, so let's just pass null. Now it's time to override the oncreate method that will actually create the database file when called. Start by writing the SQL statement that will describe the database schema. Remember to follow the contract that we created in the previous exercise. An SQL create table statement starts with create table, followed by the table name and the table description. That is a comma-separated list of each column name followed by its type, all in a set of parentheses. Here's what our SQL create statement should look like. The ID column is our primary key with auto increment, meaning that it should generate its own values each time we insert a new row. The guest name is just a text field that cannot be null. The party size is an integer that is also not null. Finally, the timestamp field is of type timestamp, and the default value is timestamp, which means the SQL database system will automatically assign the current time every time a new row is added. Notice how we've used the constant strings from the contract to programmatically generate this SQL string. This is because if we decide to rename a column in the future, we'll only need to do so in the contract, and every time we reference that column in the app, it'll automatically be updated. Once we get our string variable SQL create waitlist table ready, we can now call exec SQL on our database, passing in that string, which creates the database. The last step is to override the onUpgrade method. This is only called when the version number we defined earlier becomes larger than the version number of the database on the device. It's meant to update the database schema without losing any user data. So ideally, this should include a schema update statement. Since we only have one version so far, all we'll do here is drop the current database, if it exists, and create a fresh one. But say later on you decide to add a new column to the waitlist table, then you should change the version number up here to 2 and implement onUpgrade with an SQL statement that would append that column to the database without having to drop it. Perfect! If everything is done correctly, then you should be able to pass all the tests that we've created for you. Try to follow these steps yourself and see if you can pass all the tests. Now you can run those tests by doing a right click and going down to run database test. And when it comes up, it'll ask you which device you want to run the test on.